Experiment 1, modeling the natural world with using bread. For this experiment, you will need bread. This is bread. Also for this experiment, you will need another human being. During this experiment, take the bread and divide it evenly among the participants, and share the bread and eat it together.
All mine!
No! Share the bread!
Okay, this is the bread. We will model the bread to find the volume of it.
No, wait, no, come back with the bread! Sorry, we had some technical difficulties, but now the situation's under control. That was delicious. Well, other than that, some crumbs. Other than that, we have modeled our bread now. Do you see this beautiful graph? Well, this graph is basically the graph of y is equal to 6 minus x squared. But we can divide it in terms of x as x equals the square root of 6 minus y, and x is equal to the negative square root of 6 minus y. And we could say that we can model the bread using this function and basically having a semicircle and taking that semicircle, and do you see this side length, considering this like a side length, we can take a semicircle and basically move it along perpendicular to the y-axis and create a solid that way. And we would have a 3D image. So what we want to do is model this bread perpendicular to the y-axis with a semicircle. And so what we can actually do is use this length, since we want to find the length of the semicircle at each spot from 0 to 6y on the y-axis. We want to find all these lengths of r, which is basically representing the radius, all the way up to this very top 6 up there. And we want to find the volume using the additive of all these little the side radii. So if we have a semicircle, we can say that this is r right here, like usual. And what we want to do, the first way we want to do it, kind of look at it, is basically taking care of only one side at a time. So if we take care of only one side, we can say that the radius of the circle is this r function, r length. And if we say that, we only use a quarter circle for this side, because we'll use another quarter circle for this side. And we say that if this is r and we want to find the area of a quarter circle, that's just 1/4 of pi times r squared. So we can actually basically calculate the volume from this function. And here's some of that equation. So what we're going to do is we're going to take the cumulative of those lengths of the area of the areas basically of between 0 and 6 of the area is equal to 1/4 pi times r squared. That r squared is actually represented by the square root of 6 minus y, because the r length is defined by that function at all of these points. So we're going to substitute r with the square root of 6 minus y, and that's squared, and it's between all values 0 to 6 of that y. But we have to multiply this by 2 because we have 2 quarter circles on each side. And so that's one of the cool ways you can basically represent this function. And we can basically simplify this. So we know squared is 6 minus y. And from there, you can actually take out a 1/4 pi, and it'll come out to the outside. We've done this many times before, these equations. And then you can basically simplify the antiderivative of 6 minus y with respect to 6 minus 0 will equal that integral. And we get that 6 times 6 minus 1/2 of 6 times 6 is 36 minus 18, which is just 18. And we multiply that by pi over 2, and you get 9 pi. So the area using semicircles is of this bread is 9 pi. We can also look at the semicircle in a different way. We can look at it as if we were adding the 2 r's up. So instead of having just 1 r for each side and half a circle, we can have a whole circle for s is equal to 2r. The area of this circle will be 1/8 pi s squared, because we have half of r, and half times the half on the outside will give us the 1/8 formula. You can prove it on your own. The volume will be equal to this. We still have the 0 to 6 and the pi over 8 on the inside. But instead of just 1 r, we have 2 r because that's what s is equal to. Then you can simplify it. We have the 4 times the pi, or divided by a is pi over 2, which is, and then you have the 6 minus y, which is the square root of 6 minus y squared. And then from there you have pi over 2, you take it out, and then you can do the antiderivative, do the 6 minus 0 on the and plug it in the antiderivative, and get pi over 9. And you see that pi over 9 is equal for both of them, and therefore we can see that even though thinking about it differently, we still got the same answer. Cool. So you can do both ways. Just think through it logically, and it'll should make sense. So we can also use isosceles trapezoids to do this. Pause the video now, try it on your own, and then you can look at how I did my solution. But you should end up with 27 square root of 3, and do it kind of the same way I did it with the circles, dividing them up into 2 halves. Share the bread!
Bam! Okay, so what we have here is a cup, and we're going to find the volume of this cup. So first of all, what we need to do is look at this graph here, which is a graph of its base. It can be approximated by the equation x squared plus y squared equals 9, which can be turned into y equals 9 minus x squared. This is the base. And we're gonna find the volume by taking cross sections that are isosceles trapezoids with 60-degree base angles that are perpendicular to the x-axis. So the area of an isosceles trapezoid, like this, is 3 square root of 3 over 16 s squared. And our s here is going to be equal to 2y, because s here is the base, and it's this length right here. And here is the length of y, and it is made up of 2y, which is also equal to 2 square root of 9 minus x squared. So here I've worked out the formula for finding the volume. So volume is equal to the integral from the interval of a to b, which here is -3 to 3, which can be found by setting this equation equal to 0 and putting in the area for the isosceles trapezoid right here. And then down here I've substituted in s for its value, and as you can see, I've begun to work out the entire problem by taking the integral and finding the volume. And here I substituted in the values, and I got that the answer is 27 square root of 3 units cubed. Now here's another way to find the volume of this cup by taking cross sections of isosceles right triangles with the hypotenuse as the base. So here that area equals to 1/4 s squared, where s is equal to 2y again, and which is equal to 2 square root of 9 minus x squared. Here I've written out the formula for the volume again, which is the same except for that the area is 1/4 s squared this time. And as you can see below, I've substituted an s in for its value, and I've simplified down to this by taking the antiderivative and then plugging in the values of the interval, and I got that the area is equal to 36 units cubed. So here are the formulas that you need to not fail this topic. Up here we have the volume of solids. When you have cross sections that are perpendicular to the x-axis, the volume will be equal to this formula right here. Note that it's a of x because the cross sections are perpendicular to the x-axis. When you have cross sections perpendicular to the y-axis, the volume will be equal to this equation here. Note that the area is area of y. Down here, we have formulas for known cross sections where the s is equal to the base. For the square, the area is equal to a equals s squared. Semicircles, this area equals pi over 8 s squared, and so on.
Common mistakes, don't do them. Do not put that pi.